Hi, my name is Elizabeth Ramos, and today we're going to be going over oxidation numbers. So oxidation numbers are pretty easy to find. I'm going to teach you the solve for x method. So let's just jump right in. So here for A, we're going to try to find the oxidation number for chromium in CrO3. So things that you have to keep in mind are things that have fixed charges. So that's going to be stuff in the group 1, group 2, your halogens, that nitrogen, and your oxygen. So let's make sure to keep those in mind. So here, whatever we're solving for, we're going to make it into an x. All right, so Cr is going to be x, and then we're going to add, there's 3 oxygens, so it's going to be 3 times the charge of oxygen, which is -2. And as you can see, there's no charge on here, so it's neutral, meaning this equation is going to be equal to 0. After we have that set up, it's pretty simple. We just solve for x. So x plus -6 equals 0. So if I add 6 onto the other side, we know that x equals +6. So the oxidation number for chromium in CrO3 is going to be +6. Not too bad, right? So let's just do a few more examples to make sure we got it. Now we're going to do mercury and mercury chloride. So we're going to do the same thing. Mercury is going to be our x. Chlorine is a halogen, which means it's going to have a -1 charge. There's 2 of them, and it's going to have a -1 charge is equal to 0. So that's going to be x minus 2 is equal to 0. So that means x is going to equal +2. So that's going to be the oxidation number for mercury in that compound. Now we're going to do gallium and gallium hydroxide. So gallium is going to be x. There's 2 ways you can approach this, all right? So we can either do, we can separate this, and I'm going to show you how that's going to happen. So it's GaOH2. So Ga, there's only one, so it's just 1x. We have 2 oxygens, so plus 2 times -2. And then we have 2 hydrogens, which are +1, so 2 times 1. All right, we can do it this way. However, the way out, and that's going to be equal to 0. The way I would do it is, we know that hydroxide is -1, so we can just do 2 times -1. And this is actually the more accurate way, because I believe up here, I mean, they're going to give you the same number, whatever. All right, so then we have x minus 2 is equal to 0, so then gallium is going to be x is equal to +2. Now we're going to use phosphorus and Na3PO4. So this one's a little trickier, right? Because it trips you up because it's in the middle, right? Why? Just kidding. It's pretty easy. So we're going to go ahead and do 3 times the charge of sodium, which is 1. So 3 times 1. We have 1 phosphorus, so that's going to be x. And then we have 4 oxygens, so that's going to be 4 times -2. And again, it's neutral, so it's going to be equal to 0. So then I have 3 plus x minus 8 is equal to 0. So I have x minus 5 is equal to 0. So x is equal to +5. And that's going to be the oxidation, there we go. Whew. Oxidation number for phosphorus. And now I added this one. These 4 are actually in your book, and I added this one just because I wanted to show you guys one with a charge. So we're going to make sulfur X, all right? Same process. And now I have 4 oxygens, so it's going to be +4 times -2. However, it's not going to be equal to 0 this time because we have a charge. So now it's going to be equal to -2. Crazy stuff, right? So now we're going to have x minus 8 is equal to -2. We're going to add 8 to the other side, so that means x is going to equal +6. And that would be the oxidation number for S in this sulfate ion. So to recap, you're going to take the element in question and you're going to make that x. And you're going to basically plug in all of your known values. So your known values are going to be your group 1, group 2, your halogens, your nitrogen group, your oxygen group, And then you're basically just going to solve for x. And keep in mind that if there's a charge, it's not going to be equal to 0. It's going to be equal to that charge, as we saw there. And that's how you find oxidation numbers.